So now we're going to look at some notation when we do second derivatives or third derivatives or any derivatives. All that we're going to do is take the derivative of the derivative and you have the second derivative. And if you took the derivative of the derivative of the derivative, you would have the third derivative. Okay? Notation-wise for the first two is really straightforward. Notation-wise for the last one gets a little bit different. Okay? Now, notation-wise for the last one thing that I always think of when I'm doing notation of the last one, when you do d dx of something, that means take the derivative of that something. So if I did d dx of d dx, I'm doing that twice. That's why the squared on the top goes with just the d. And maybe the bottom should have brackets, but it doesn't. So that's the notation for the second derivative. Your new spot is right there, in front of Peter.
Really, Peter? I just prefer being here.
So all we have to do to find a second derivative is find our first derivative and then find our derivative after that.
Third derivative. How many times do you derive?
You can derive things forever. Yes. Just, sorry, write a 2. Sometimes you'll see it like that. Okay. Usually, though, with 2, we'll do 2 lines. And after 2, when it gets to bigger numbers, then they start putting numbers inside. Yeah, then you put little numbers in there. So if we did our first derivative, and I change that x to an x to the negative 1, this would be our first derivative. And then our second derivative would be your second derivatives. So it really isn't learning anything too crazy, because if you can do the derivative, you can do the derivative again, and there's nothing too crazy happening with the second derivative.
We have those crazy things that run our test.
However, yeah, if your first derivative gets really, really long, then your second derivative could get extremely long. Okay, but that's why we try to simplify things as best as we can. So here we want to find the second derivative of this. We're going to do this by first finding our first derivative, dy dx. It's a chain rule. The 3 would come out in front. And then we'd have to multiply by the derivative of the inside. We might take our time to simplify this a little bit.
You put a bracket with the squared bracket, like 3x. Oh yeah, you put the bracket.
Oh, I put a, yes, thank you. There we go. And then now we'll do our second derivative. And our second derivative is going to have a product rule and a chain rule. So here I would have 2. Oh, let's keep one the same. Let's keep the first one the same. Derivative of the second one, plus keep the second one the same. Derivative of the first one, which will have a chain rule. Okay. So the fact that we had a product rule and chain rule in our second rule made our final answer quite long. So there's sometimes, if you know that you're going to be needing to find your second derivative, you might look at your original function. And I'm just going to grab this to a new screen. You might look at your new function and say, maybe cubing it's not that bad. Maybe I'm going to expand this. So, do you remember how to use Pascal's triangle to expand something? So y will equal, I'll use the coefficients 1, 3, 3, 1 from Pascal's triangle here. And then you would have your first term cubed, then your first term squared, then your first term 1, and then none of your first term. Your second term, no times. Your second term, 1 time. Your second term, 2 times. And then your second term, 3 times. And multiplying this out gives me y equals x to the 6th plus, this will be, or actually minus 9 x to the 5 plus, did I put the squared in the wrong place there again? Yeah. Wow. That was my big eraser. Okay. That'll be 27 x to the 4. And the last one will be negative 27x cubed. But now that we've done that, and you have a simple polynomial, look how easy your derivatives are from there. It's going to be 6x to the 5 minus 45x to the 4 plus, okay, the numbers get a little bit big. Is that right? 108x cubed minus 81x squared. And then we take the derivative of that for our second derivative, 30x to the 4 minus 180x cubed plus 324x squared minus 162x. And that is the simplified form of this. On the other one, you could factor out an x to the squared. And this one would be, where did those go? Perfect. This one would be easier to keep going with if you had to find the third derivative or the fourth derivative. So sometimes simplifying early, although not very enjoyable, may prove to be easier to work with as you go along.
The chance of you making an error on this is less than the other one.
Well, this has some bigger numbers. There might be this one.
I think this one has more work, but like the other one has like there's more complicated stuff to it. I guess. I think this one's easier.
So both would be fine. You just have to decide which route you want to go with.
A lot easier to explain if you look back like that's wrong.
Okay.